We're going to talk about whole number multiplication and the standard algorithm using the example 24 times 36. The standard algorithm is closely related to the partial products algorithm. So on the left here, I went ahead and filled out the work for the partial products algorithm. Recall that the product of two numbers can be represented by an area model. And in partial products, we think of each of the factors in expanded form. So 24 becomes 20 plus 4, and 36 becomes 30 plus 6, and our algorithm is 6 times 4, 6 times 20, 30 times 4, 30 times 20. Add up the four partial products, and I get 864, which is the product of 24 and 36. The standard algorithm is just a more efficient version of the partial products algorithm. So let's go through step by step and see how they're related. To start with, I take 6 times 4 and 6 times 20. In the standard algorithm, I'll follow the same pattern, except now I'm going to say it like this. 6 times 4 is 24, carry the 2, 6 times 2 is 12, plus 2 is 14, and record it all on one line. Now take a look here, guys. If I take 24 and 120 and add them together, I get 144. So the sum of these two partial products gives me 144. What does this end up being? I have 6 in both of these. This is going to be 6 times the sum of 20 and 4, 6 times 24. If I represent this in my picture, I have 24 along the top, and I need just 6 down here. So I'm still going to do the second factor in expanded form. And 144 is this whole area, and it corresponds to the sum of these two partial products. Now, in the partial products algorithm, I said 6 times 20, and in the standard algorithm I said 6 times 2, and all I'm doing is taking advantage of our base 10 number system and how the location of the number tells us the value. So what I was really thinking here, or should have been thinking maybe, was 6 times 2 tens is 12 tens, plus 2 tens gives me 14 tens. It's kind of a mouthful. And my 14 tens, if you notice, they're recorded in such a way that I didn't need to say 14 tens. The location of the number tells me its value. So our place value system, base 10, does the heavy lifting in this algorithm. Let's go to the second step. So I'll switch up my colors here. So here I did 30 times 4, 30 times 20. I'll follow the same pattern here, except it'll sound like this. I'm going to put a placeholder 0. 3 times 4 is 12. Write down the 2. Carry the 1. 3 times 2 is 6. Plus 1 is 7. So again, notice that if I take 120 plus 600, I get 720. The sum of these two partial products gives me 720. So it was just more efficient. I didn't have as many lines of work here. And this is 30 times 20 plus 4, or 24. So in my area model, 30 times 24 is this region at the top, which corresponds to the sum of these two regions, of these two partial products. So let's talk about this placeholder 0. So our placeholder 0 right here is because for my 3, I'm really treating this as 3 tens. So I've moved over to the tens place, but as I work through my multiplication, I'm treating this as a single digit 3. So to compensate for that, the tens, I put a placeholder 0. If I had a third digit here, if I had something in the hundreds place, let's say that I had like 136, I would treat it as a 1, but it would be 100, and I would have 2 placeholder zeros. So I just fill in the placeholder 0 right here. I can add these numbers together and get the exact same total.